Hi, welcome to my research presentation. My full name is Mohammad Arifin Khan. Today's my research title is Enhancement of Detection of Diabetic Retinopathy using Harris-Hawkes Optimization with a Deep Learning Model. I'm working with Bangladesh University as a full-time lecturer for the Department of Computer Science and Engineering, Dhaka, Bangladesh. I like to submit my today's research presentation for the consideration of the award manager and the management team of Cardiology 2022, International Research Awards on Cardiology and Cardiovascular Medicine. Status of this research. Our research has published by Hindoi, journal named Computational Intelligence and Neuroscience, Volume 2022, Article ID 8512469. This research has received 4th of March 2022, accepted 29th of April 2022, and published 26th of May 2022. My act like a corresponding author for this research. I also attached the available online link at the bottom of this slide. Introduction. In today's world, diabetic retinopathy is a very severe health issue which is affecting many humans of different age groups. Due to the high levels of blood sugar, the minuscule blood vessels in the retina may get damaged in no time and further may lead to retinal detachment and even sometimes lead to glaucoma blindness. If diabetic retinopathy can be diagnosed at the early stages, then many of the affected people will not be losing their vision and also human lives can be saved. Literature review. Today's world of advances in deep learning has changed the way in which healthcare is handled recently, which allows the medical practitioners effectively diagnose and treat diseases. Several researchers across the globe attempted to address the task at hand effectively. From the evaluation of various deep learning-based classification, detection models have been drawn in this century. Many researchers are working in this area across the globe. Table 1 lists the review on deep learning applications in diabetic retinopathy and other data sets, which I have to mention by my next slide 6. By table 1, I have to provide my literature review where I have to attach 7 different categories of references and each references I have to separate by dataset, method used, evaluation matrix, and research challenges. Summary of literature review. According to the section of literature review, it has seen that all of their works did not find out a prominent method or model to improve the detection of diabetic retinopathy. Moreover, it is also observed that several machine learning and deep learning methods have been applied on the available data sets of diabetic retinopathy, but they were unable to provide the better results in terms of accuracy in pre-processing and optimizing the classification and feature extraction process. Objectives and contributions. The main objectives of this research work are optimizing the feature set extracted from the image dataset and proposing the best classification algorithm through experiments. The contribution of this work are as follows. 1. A principal component analysis algorithm has been used for feature extraction and selection from the image dataset. 2. A dimensionality reduction using the Harris-Hawkes optimization, whose short abbreviation is HHO algorithm has been proposed in order to optimize the feature set further. 3. A deep convolution neural network has been used for DR, whose full abbreviation is Developed Diabetic Retinopathy Detection and Classification. The proposed work has mentioned by as well as number 4, where a combination of deep neural network, PCA, whose full abbreviation is the Principal Component Analysis, and HHO has been implemented and compared with the various machine learning models such as KNN, whose full abbreviation is K nearest neighbor, SVM, whose full abbreviation is Support Vector Machine, and XGVOOST classification algorithm. And number 5, the numerical outcomes of this experiment along with comparisons are encouraging and are better than enhanced math heuristic methods in terms of accuracy, precision, recall, specificity, and sensitivity. Proposed model. Harris-Hawkes optimization technique is a gradient-free mathematic heuristic swarm-based nature-inspired algorithm. The key concept of this algorithm is the utilization of dynamic and nature cooperative hunting behavior of Harris-Hawkes for victims. The main objective advantages of the HHO algorithm are the possibility of getting a global optimal solution, high convergence speed, high accuracy, and better quality. I like to present the HHO algorithm pseudocode in here also. And this pseudocode is fully guided by the HHO algorithms, which we have to apply it with our research. The working mechanism of the HHO algorithm in different stages depicted in Figure 1. Figure 1 various stages during the HHO algorithm. Broadly, the algorithm consists of 2 stages, exploration and exploitation. Exploration stage. The exploration stage models the behavior of the Harris-Hawkes search process to detect and spot the victims. The exploitation stage models the intelligent harm. The change in the location of the hooks at each iteration during the exploration stage is mathematically modeled by the equation 1, where C function I is the current location vector of hooks. Ci plus 1 is the function, is the location vector of hooks in the next iteration I. C victim, the function of I is the location of victim. C, the average is the average location of the current population of hooks. The small letter of C, N1, N2, N3, and N4 are random variables whose values are to be updated at each iteration between the range of 0 and 1. The average location of the hooks is calculated using equation 2, where Ck, the function of I, denotes the position of hooks after iteration I, and capital M represents the number of hooks. Exploitation stage. In this stage, the hooks execute. In this stage, the hooks execute the sudden punch on the envisioned victim, which was spotted in the exploration stage. The modeling of the victim energy plays a vital role here, and it is defined as follows by the equation 3, where the capital G represents the victim escaping energy. Capital I is the maximum possible iteration. Capital G naught is the initial energy state, and it is a random variable whose value changes between the range of -1 and 1 in each iteration. Subsurrounding approach has been modeled as follows by the equation 4 and 5, where delta C, function of I, is the difference between the location vector of the victim and the present location in iteration I. Hard surrounding. Here, the current locations of the hubs are updated using by the equation 6, and this concept with one hub is illustrated in figure 2. Subsurrounding with progressive quick dives. This scenario is applicable if absolute Z is greater than or equal to 0.5 and small q is less than 0.5. This means the hooks construct a more intelligent subsurrounding strategy due to the victim still has sufficient energy to escape successfully In real time, the victim chooses random escaping patterns and leapfrog movements. To model this concept, the leapfrog random walk notation is adapted into the HHO algorithm. The LF concept helps to mimic the real-time zigzag movements of victim and hawk's sudden, irregular and quick dives around the escaping victim. To catch the victim in the adverse condition, the hawk's real behavior is to choose the best possible dive at every step and reach closer to the victim. To mimic this behavior, the hawks can compute their next movement based on the following rule by using equation 7. Sometimes the hawks choose to drive according to LF-based patterns as defined in the following equation by 8, where the capital D is the problem dimension, capital B is a random, one multiple small d dimensionally vector. The Levy flight function is computed using the following equation 9, where beta is a constant with a value of 1.5 and P and Q are random variables with a value between 0 and 1. Therefore, in the sub-surrounding phase, the latest positions of the hawks can be defined in the final stage using the following equation 10, where capital A and capital V are attained using equation 7 and 8 respectively. An instance of the above modeling concept for one hawk is illustrated in figure 3. Hawk surrounding with progressive quick drivers. This scenario is applicable if absolute G is less than 0.5 and small q is less than 0.5. This means the hawks execute hard surrounding before the sudden pounce to catch and kill the victim due to the victim energy has been exhausted. The hawks update their locations in the context of hard surrounding using the following equation by 11, where the capital A and B are attained using equation 12 and 13 respectively. Where C ever is the function of I is computed using equation 2 and in instance of the above modeling concept with overall vectors for one hawk is illustrated in figure 4, which represents in the next slide. The key feature of HHO algorithm, which has a prodigious impact during the exploitation stage, is that it exhibits a series of search strategies and picks the best move at each iteration. The HHO algorithm tries to improve the superiority of the solution throughout the optimization process by progressive choice arrangement by search agents. Finally, the computational complexity of the HHO algorithm has been analyzed and computed based on 3 tasks: initialization, fitness evaluation, and updating of hawks. Results and explanation. Using tools and resources. 1. There were 1,151 instances and 20 attributes in the diabetic retinopathy dataset used in this study. 2. Table 1 lists the characteristics of the dataset used in this study. 3. Except for the output layer, all of the layers used the subsign activation function. 4. The experiment was conducted using the diabetic retinopathy diversing datasets from the UCI ML library. 5. The features extracted from the image dataset were used to create the attributes in this dataset. And 6. The Python experimentation was carried out on a personal machine with 8 GB of RAM. Matrix used in the evaluation of the model. The suggested model is evaluation using the matrix listed below. Accuracy. It is also known as the ratio of the number of right assessments of the total number of assessments. The following equation can be used to calculate the accuracy, where TPOS is true positive, TNEZ is true negative, FPOS is false positive, and FNEZ is false negatives. Specificity. It is the percentage of true negative successfully detected by the classifier while taking the test. The following equation is used to calculate it, where I have to mention by the equation 14. Sensitivity. During testing, it is the percentage of true positive successfully detected by the classifier The following equation is used to calculate it, where I have to mention by the equation number 15 in this slide. Precision. Precision is an important metric for measuring extraction length. It expresses how much of the total forecasted positive occurrences the classifier identified as positive as shown in the following the equation 16. Recall the percentage of positive cases classified as positive by the classifier is determined by recall when there is a large cost connected with the false negative as stated in equation 18. The recall is a performance parameter used to detect the optimal model, which I have to mention by the equation 17. Performance analysis. The DNN-PCA model was built using a sequential strategy for testing the proposed model. The dataset was divided into two scenarios for cross-validation, with 80% utilized for training and 20% used for verifying every 64 records. To determine the optimal activation function for a dataset of 50 epochs and a batch size of 64. Testing was performed on many activation functions such as RELU, ELU, TANH, softmax, SELU, softplus, and subsign. Results and explanation. The subsign activation functions, as shown in figure 5, provided the best average training and testing accuracy. As a result, the softmax activation function is used to evaluate the model on dense layers. As shown in figure 6, the Atom optimizer offered the highest level of accuracy. As a result, the Atom optimizer is selected for input and other dense layers experimentations. For the output layer, a Sigmoid optimizer is employed. The model showed an excellent training and testing accuracy with 5 layers, as shown in figure 7, with the accuracy level starting to decrease with 6 levels. As a result, a 5-layer deep neural network was deployed in the experiment. The model provided better results in providing a good average training and testing accuracy with 600 epochs, as shown in figure 8, with the testing accuracy beginning to dip with 650 epochs. As a result, 600 epochs are used to train a deep neural network. Figure 9 to 14 show how the accuracy, precision, recall, sensitivity, and specificity of machine learning models are evaluated. These graphs show the ML models based on PCA, HHO provided the best results rather than the other two scenarios, ML with PCA and ML without dimensionality reduction. PCA added HHO, on the other hand, improves the performance of ML algorithms, while cutting training time in half, as shown in figure 15. When the original dataset was employed, it fell victim to overfitting, which had a negative impact on the results. The performance has been improved even though the size of the dataset was increased by 2 times, and the same is shown in the figure 13. Conclusion: the proposed model results were compared to the outcomes of the most popular machine learning algorithms, with the finding demonstrating the model says superiority in terms of specificity, precision, accuracy, recall, and sensitivity. Nevertheless, in the event of a low-dimensional dataset, the model says ability to perform well may be limited by the possibility of overfitting. Therefore, our proposed model encourages the researchers to pursue similar research in a variety of other health disciplines using high-dimensional data. I like to present my references in here by the slide number 28. In here, I have to provided 6 different categories of reference. Most of the reference is come from 2021, And few of the references I have added with my next slide, 29. In here, I have to edit reference number 7 up to 13. And I like to edit in here the reference year of the 2022, as well as a few of the reference I have to attach from the year of 2014, 2000, 1989, as well as I have to attach the year of 2019. Thank you to the award manager and the management team of Cardiology 2022, professors and audience.